Alright, so today we are going to be talking about different statements that we use while we are in geometry. So we have the very first one, our big one, the one that every other one goes off of. We have what's called our conditional statement. So remember, a conditional statement, this is a statement that is written in if-then format. So if something happens, then, as an implication, something else is going to happen, all right? My hypothesis is the part of my conditional that comes after my if. And then my conclusion, then, we kind of can figure this one out, comes after then. Oh, spelled after wrong. There we go, after. All right, conclusion comes after then. And then, once we figure out if these conditional statements are true or false, if they are false, we need to make sure that we back it up with a counterexample. Okay? Remember, a counterexample is something that disproves a statement. This could be a drawing. This could be an equation. This could be an explanation. There's a lot of things that they could be. All right, as long as it disproves that statement that you are saying is false. All right, so let's take a look at three conditional statements. Okay, first one. If I am running, then I am doing cardio. Well, if you're out on a run, you absolutely are doing cardio. So this is a true statement. Since it's true, no need to provide a counterexample. We're set, we're done. Hypothesis, I am running in green, and then that conclusion is I am doing cardio, that's in yellow. All right. Let's just do the hypothesis and conclusion of the next two then while we're at it. So, if 2y equals 10, then y equals 5. My hypothesis is 2y equals 10. And then if x squared equals 64, then x equals 8. My hypothesis, x squared equals 64. Conclusion, the part that comes after then. So y equals 5, x equals 8. Alright, let's figure out if these things are true or not. Alright, let's look at this second one. If 2y equals 10, then y equals 5. Alright, well, we know the laws of algebra. If I divide 2 by both sides, that gets me y equals 5. That's absolutely true. Gotta be true. There is really no other way that we can think of that would disprove that equation. Okay? Go ahead, pause the video, see if you can figure out the next one. Alright, let's see how you did. X squared equals 64. Does x equal 8? Well, if I do 8 squared absolutely does equal 64. But we have to remember, is there something else that could, when I square it, equal 64? And hint, there absolutely is. If I squared negative 8, right? Negative 8 squared is 64. So this statement is false, right? Counterexample to that, since it's false, x equals negative 8, all right? All right, let's move on to talking about these implications on all these statements, okay? So I have all of these variations on these conditionals. We have our converse, our inverse, and our contrapositive, all right? So the converse, remember, let's start there. Converse. This flips my hypothesis and conclusion. Just going to shorthand that. Hype and conclusion. All right? My inverse negates my hypothesis and conclusion. And then last, we have what's called that contrapositive. The contrapositive negates the converse. Okay? Now think too, remember, negate is just a fancy word. In our case, for this class, not. Okay? So, let's say I have this conditional statement. If x squared equals 64, then x equals 8. We just took a look at this one. So we have this conclusion, x equals 8, this hypothesis, x squared equals 64. Okay? So we determined this original statement, we determined this to be false. That's what we said. Alright. So if I were to write the converse to this statement, again, the hypothesis and conclusion, they just flip-flop. So the converse would say, if x equals 8, then x squared equals 64. And that's a true statement, 100%. If I take that 8 and I square it, I get 64, boom, done. Okay? All right, let's look at the next one. So if I negate this, so if x squared equals 64, then x equals 8. The inverse, again, doesn't flip anything, but it just negates the order that we have. So this would read, if x squared does not equal 64, then x does not equal 8. So x squared does not equal 64, x does not equal 8. Take a second, think about it. All right, what'd you get? If x squared doesn't equal 64, is there any way that x could be 8? No, not necessarily. No, that's true. Okay? If x squared is not 64, then x cannot be 8. Okay? And then my contrapositive negates the converse. So if I take a look at the converse, if x equals 8, then x squared does not equal 64. Okay? So let's walk through this. If I write this contrapositive, I have if x does not equal 8, then x squared does not equal 64. If x doesn't equal 8, is there still a way that x squared could equal 64? Yes, there is. Yes, there is. Again, if x were to be negative 8, we could still get that x squared is 64. So that is possible, so this is a false statement. Okay? So again, this is kind of just the ordering of the converse, inverse, and contrapositive. All right, last thing we talked about was the biconditional. So remember, a biconditional statement is written in if and only if form. Okay? And we can break a biconditional down into two conditionals. Remember, a biconditional is really equivalent to a conditional and its converse. Okay? So let's say I have this biconditional here. I am in Cleveland if and only if I am in Ohio. I'm just going to type this one out. So I could do conditional 1. Conditional 1, if we kind of look, we have these two different pieces. We have I am in Cleveland, and then we have I am in Ohio. So conditional 1 would read, if I am in Cleveland, I'm just going to do CLE to short it, then I am in Ohio. And this is true. If I'm in Cleveland, I'm absolutely in Ohio. If I can write this second conditional, this then says, if I am in Ohio, then I am in Cleveland. This, however, is false. Okay? A counterexample to that would be literally anywhere else in Ohio. Cincinnati, Dayton, Columbus. Okay? So since one of those conditionals is not true, the biconditional is false. Okay? Alright, and we have this next one. 3 segments are coplanar if and only if they are on the same plane. So, same thing. Conditional number 1. If I identify these two parts, I have, let's start with 3 segments are coplanar, and then I have they're on the same plane. Okay? Alright, conditional number 1. If 3 segments are coplanar, then they are on the same plane. Well, if 3 segments are coplanar, they're absolutely on the same plane. That's true. That's the definition of coplanar. Second conditional. This would read, if 3 segments are on the same plane, then they are coplanar. And this is also true. Again, definition of coplanar. So, since both of those conditionals are true, we know for a fact that this biconditional now is also true. And again, the reason is because the original conditional is true as well as its converse.